1.1, first lesson in the book. So we have some vocabulary to go over, and we'll keep hitting the vocabulary as we go through, but I want you to write the vocabulary down. You can stop, the video if you need to get everything written. And I'm having major issues with the pen, so hopefully I will get better at it. Variable is usually a letter that represents an unknown value, usually some number. And this is right at the top of page 2 in your book. It says variable is a letter to represent one or more numbers. The numbers that are values, the numbers are the values of the variable. So an algebraic expression then is an expression that includes at least one variable. So let's do an example like x plus 6 minus 8. That would be an expression that has one variable in it, so it has a missing part. So until I would know what x is in this problem, I would not be able to solve that. Okay? So then we have power. Power is, it shows repeated multiplication. So let's do one like, let's do 3, what they have in the book. I'm over on the next page, page 3. Let's go 3 to the 4th. This is a power. This shows repeated multiplication. The base is this big number, the 3, and the exponent is the 4. The exponent tells us how many factors of the base to have. So there's going to be 4 of them. 3 times 3 times 3 times 3. So that is repeated. And then that tells us, the base tells us, the exponent tells us how many times to repeat that base. So then you would multiply it out to find out what its value is. So a lot of this is review if you think about going back to the math that you've had before. So here's example number 1, evaluating algebraic expressions. So you can see as we go through these examples, we're evaluating the expression when n equals 3. So here we have 13 times n, so I'm substituting in right here 3. So it'd be 13 times 3. So you can, and you're writing these examples with me. So we substitute in 3 and we get, multiply, 39. So go ahead and write that for your first example on number 1. 9 divided by n, so here we're substituting again the 3n. Notice I said divided by, that line, it's not 9 over n. Say 9 divided by n is 3, and 3 goes into 9 3 times. So a lot of it is just substituting numbers into the right places, doing the correct operation, and then also knowing your facts to be successful at doing that. So C is n minus 1, and n is 3, so we put in 3 for n right here, so 3 minus 1, which in this case comes out to be 2. Subtract, we get 2. Again, n plus 8, so we put in the 3, 3 plus 8, which is 11. So we go in there, they substitute it, and then you add, and you get 11. So here's our guided practice. You're doing this along with me. Evaluate the expression. Remember, evaluate means give me the answer. So when we have on this right here 6y, that means to multiply, so it's 6 times 2, because y equals 2, which is 12. So we can see right here, 12. 8y, that's 8 divided by y. 8 divided by 2 is 4. Let's see if we get them right. Substitute 2 in, 2 plus 4 is 6, and I wasn't showing my work nice, writing it out, don't make any mistakes. 11 minus y, that's going to be 11 minus 2, which is 9. Okay, example number 2. It's evaluate an expression, and this is at the top of page 3. So you can see in evaluating the expression, we have a situation about movies. The total cost of seeing a movie at a theater can be represented by the expression A plus R, where A is the cost in dollars of admission and R is the cost in dollars of refreshments. Suppose you pay $7.50 for admission and $7.25 for refreshments. Find the total cost. Well, you just take those, you know what each of those letters stand for, and you just substitute it in. It would be $7.50 plus $7.25. And we know we don't a lot of times think of it this way. We know we added, but a lot of times we don't think. And I know 7 and 7 is 14, and 50 cents and 25 cents is 75. So you would have spent $14.75. Well, that's a lot on refreshments, I think. Kind of expensive for one person. So here's their solution. They're going to substitute the values in. They're going to add, so your total cost. Okay, so now we're at example 3, reading and writing powers. We talked about bases and exponents. So first off, they have the power, talking about reading them, writing them in words and as a product. So first thing we have, this right here is 7 to the first power, and the product would be just 1 7, because the exponent tells us how many of the bases to repeat, and since there's only one, you just have 1 7. This is 5 to the second power, or 5 squared, which means 5 times 5. And that's the product. They're not asking us to evaluate it, they just want us to write it as a product. Many of you will make the mistake right here and do 5 times 2. So you have to be really careful. That's not what an exponent means. An exponent is how many of these bases do you write. So it's very important to remember that and not get caught up in that. Ooh, this one's messed up. Look at that C. 1/2 to the third power, or 1/2 cubed. When you see the little 3 right here, you can say cubed. And when you see the 2, you can say squared. That's the only little shortcuts. That the rest of them you have to say to the whatever the number is. So there is 1/2 to the third power, or 1/2 cubed, and it would be 1/2 times 1/2 times 1/2. 1/2 times 1/2 times 1/2. I think I lost count in what I was saying there. Then we throw in some algebra. We have to have some letters in this stuff. I always say this is a little twist. This is z to the 5th power, and we just say it like it is. And it would be z times z times z times z times z. That's all we can do until we know what z is. So that's as far as we can go. So here's some guided practice. Number 5, what if in example 2, suppose you go back to the theater with a friend and see an afternoon movie. You pay for both admissions. Your total cost in dollars can be represented by the expression 2A. If each admission costs $4.75, what's your total cost? So you pay for both of them. So you're just going to take $4.75 times 2. So double that. I don't know, I would probably take 4 times 2 and get 8, and take 75 cents times 2 and get $1.50. So it would cost you $9.50 for both of you. And save money, bring your own treats, I guess. Go to Walmart and buy $1 candy or something and take it in. I guess you're not supposed to do that, but okay, guided practice going on. Write the power in words and as a product. So here's the power. So in words, that would be, let's see if I can write it, 9 to the 5th power. And my cursive is terrible, but it seems to write better that way. That's going to be 9 times 9 times 9 times 9 times 9. 5 of them. And I probably wrote right over where they'll put the answer, so I did. There we go. So this one is going to be, I'll try to write a little higher, 2 to the 8th power. 2, 1, 2, 3, 4, 5, 6, 7, 8. That would be 2 to the 8th power, so 8 2's. Let's see if they agree. 2 to the 8th. There's my 8 2's. I don't know why those numbers are mixed up. That would be n to the 4th Example number 4, evaluating the powers. Evaluate means that you're coming up with that answer. You want to find the value of something. So right here they give us x to the 4th when x is 2. So we substitute in. We go 2. It would be 2 to the 4th, which means 2 times 2 times 2 times 2. And evaluate means find it. So 2 times 2 is 4, times 2 is 8, times 2 is 16. And I just draw those lines so I keep track of my 2's and I don't leave any of them out. So 2 to the 4th power is 16. N to the 3rd when n equals 1.5. So let's see, we go substitute in my pen going again here. 1.5 cubed is another way to say it. To the 3rd power means 1.5 times 1.5 times 1.5. Well, 1.5 times 1.5. I'll multiply these out. 5, carry the 2. That's going to be a 7, a 0, a 5, a 1. And there's 2 decimal places up here. Remember, you have to put that many in your answer. That's 2.25. And I got to take it times another 1.5. So I forget about the decimal points while I multiply, and I just multiply 5 times 5. I do these. It's 12. Carry the 1. That's going to be 11. Placeholder 5, 2, 2. 5, 7, 3, 3. And now I have 3 decimal places up here. There's 2 here, 1, 2, and 1 here, 3. So I go in 3. 1, 2, 3. So I think the answer is 3.375. Oops, sorry about that. So let's see if that's true. I don't know if they give us the answer. Yeah. So there's my x to the 4th, 2 to the 4th. .5 to the 3rd, you multiply 3 point, you can see it in there, 375. Okay, so our guided practice, evaluate this expression, x to the 3rd when x equals 8. So it's going to be 8 cubed, or 8 to the 3rd, which is 8 times 8 times 8. 8 times 8 is 64. 64 times 8, then this one right here would be 2, carry the 3, that's 48. 512, and boy does it help to know your facts right there to multiply, make it a lot quicker for you. So let's try this one. K to the 3rd is 2.5 to the 3rd, so that's going to be 2.5 times 2.5 times 2.5. Boy, they're making me work, aren't they? 2.5 times 2.5, which is really just 25 times 25, which I think is 625. I better check it. Look at that, it was 625. And I got 2 decimal places up here, so I got to put 2 decimal places in my answer. So 6.25 times 2.5. So 5 times 5, whoop, my pen's not going to work, 25, carry the 2, 12, carry the 1, 31, placeholder 0, carry the 1, 5, 12, 5, 2, 6, 5, 1, put in 3 places, 1, 2, 3 places, so it's 15.625 is my answer, and that one was 512. Let's see if they give us those. 512 and 6.25. I don't think that's right, is it? Oh, okay, look in your book, guys. Number 10, this is a mistake. It says k to the 2nd power, and this one says k to the 3rd. So that's where the mistake, there's a mistake right there. The book says to the 2nd, and if I would have done that, then it would have been 6.25. So that's a typo on the PowerPoint. All right, we're still doing guided practice. Evaluate the expression d to the 4th when d equals 1/3. So that's going to be 1/3 to the 4th. So So 1/3 times 1/3 times 1/3 times 1/3. And we got to remember about fractions. It's top times top, bottom times bottom. So we multiply all of those numerators. 1 times 1 times 1 times 1 is 1. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. So the answer is 1/81. 1/81st. See if it agrees. Yep, there it is. Doesn't like fractions very well. It always messes up the typing on it. Okay, for example, guided practice for example 5. Where is example 5? Do you guys see example 5? Let's go back here. Looks like we skipped example 5, so I'm going to go right here and just talk about example 5. I think, well, it's got those stories. Let me go to this one, to the picture. So let me just read example 5. Each edge of a medium-sized pop-up storage cube is shown is 14 inches long. So it throws in here, ooh, this is kind of, let's go back to, in our notes here, it throws in here area and volume. All right, so take a look at this area and volume. We have a square, and they give you a picture of a square, and the area is side times side. So that's s squared to find the area of a square. Okay, now volume is how much something holds, so we're going to talk about volume of a cube here. So the volume of a cube is s to the third. Do you see the exponents? That's why they're having us do this, is the exponents. So a cube is, you know, like this, like a die, or like this, it's like a cube that you can fill it up. Okay, that's volume, is filling how much something can hold. So it says each edge of the medium cube is 14 inches long. So I'm really bad at drawing 3D pictures, but here's a cube. Okay, and each edge is 14. Like that. Each one of them would be 14. So it says the storage cube is made so it can be folded flat when not in use. Find the volume of the storage cube. Okay, volume is s to the third, so each side is 14, so it would be 14 to the third. 14 times 14 times 14, which is 2,744. I cheated. I looked in the book to help me. So, okay. So then the guided practice says, suppose the storage cube is folded flat to form a square. Find the area of that square. So if it's folded flat to find a square, the edges are still, it'd be flat like this. The edges are still 14 by 14. So that one would just be 14 times 14, which is 041, 196 square, what was it? I don't even know the right label, inches, square inches. Okay, so we have volume, and we also have the area when it's folded flat. When it's folded flat, it's just a flat square. So 196 inches squared. So sorry I didn't have example 5 in there, but we kind of made do. It was the same one that goes with the guided practice. So that's it, I believe. That's all. We'll see if I got it recorded.